Now what happens when we pour acid over metal? Like you can take a conical flask, put some zinc granules in it, and then pour acid. Hydrochloric acid. What we get is hydrogen. Now how this happens? Zn plus HCl gives us ZnCl2 plus H2. Similarly, if instead of hydrochloric acid we pour sulfuric acid, what will happen is we will get zinc sulfate plus hydrogen. Now what has happened in both these cases? Zinc has replaced hydrogen. Now can this be done only with zinc? No. It can be done with other metals as well. For example, you can take iron. What you will get is ferric chloride and hydrogen. You can even do it with aluminium. But the vigorousness is not same. With some metals it is more vigorous. Now for example, why we don't ever use sodium for lab preparation of hydrogen? Because sodium and potassium are very reactive metals. The reaction will be very vigorous and the hydrogen produced can catch fire. Why? Because hydrogen is a combustible gas. Even here, when we brought the flame near it, there was a sound of pop. If there is enough hydrogen, it can even burn with a blue flame. So this shows that whenever acid and metal combine with each other, what we get is salt and hydrogen. So the general equation will be acid plus metal gives us salt plus hydrogen. Now you understand why metal gets shining when we use some kind of acid, maybe imli, maybe lime juice. The simplest method that ladies used to use at home was that they would use lime juice or they would use tamarind juice to shine their utensils or the brassware or the puja utensils. So the acid is able to act on metal, but then why don't we use the concentrated acid? Because then the reaction will be so much that there will be corrosion. So we can't do that. We will use only the weak acids. Now the second property is, what will happen if we put acid and base together? Let us see what is going to happen. Acid plus base gives us salt plus water. Let's see how. HCl plus NaOH. Now HCl being acid is sour, NaOH is bitter, and what we get is a salty thing. But now instead of hydrogen, we will get water. NaCl plus H2O. H2SO4 plus KOH, K2SO4 plus water. Let's do more equations. HCl plus CaOH twice gives us CaCl2 plus H2O. H2SO4 plus MgOH twice give us MgSO4 plus 2H2O. Now, so whenever acids are mixed with base or vice versa, that is base is mixed with acid, what we get is salt and water. And in a way you can say that base neutralizes the acid or the vice versa. So these kind of reactions are called neutralization reactions. Now you know the stomach produces hydrochloric acid, which is needed to kill the germs and also to change the medium from alkaline to acidic medium. But sometimes if we take very rich, spicy, fatty food, or just because we like the food, we eat in excess, then later on what happens? We get a burning sensation here. This burning sensation is called acidity. How can we cure it? You can take lot of water, you can take cold milk, and otherwise you take milk of magnesia, you can take soda bicarb or ENO. Why do we take these things? Because in all these things there is a basic medium. So when these bases are taken, they are able to neutralize the hydrochloric acid and our burning sensation gets cured. So what is this example? It is an example of neutralization reaction. Similarly, if a honey bee stings you, why do we get that burning sensation? Pain, because it has released an acid called methanoic acid. And in that case also, it is advisable that some kind of base is rubbed on it. And as a result, immediately you will be cured. Sometimes they even say that rub something which is made up of iron. Now iron is a metal, and so that also can neutralize, not I shouldn't say neutralize, but reduce the effect of acid. Another case of methanoic acid is in a plant which is very prevalent in hill stations, the nettle plant. This nettle plant has hair-like structures on its leaves which are stingy. So if by chance they get rubbed on your skin, they produce methanoic acid and there is a burning sensation. So in that case, if a tall plant is rubbed over it, the burning sensation goes away. Once again, an example of neutralization reaction. So like this we find that in our daily life also there are a lot of neutralization reactions that we are using. Another property about acids is that they not only react with bases, which are the hydroxides, they even react with oxides. You take tuna, the quicklime, which is calcium oxide. Pour over it hydrochloric acid. You will get calcium chloride and water. Similarly, if you take sodium oxide, pour sulfuric acid, you will get sodium sulfate and water. So here what has happened? Basic oxide or the metal oxide plus acid is giving us salt and water. But this doesn't happen only in acids. The bases are also able to react with acidic oxides. For example, one of the acidic oxide is carbon dioxide, other is carbon monoxide, nitrogen dioxide, then sulfur dioxide, sulfur trioxide, and so on. So if you pass carbon dioxide through calcium hydroxide, what you will get is calcium carbonate plus water. So again it is acidic oxide plus base gives us salt plus water. See, whenever such examples are there, you must write as many equations as possible. That will give you a practice in equations. Sodium hydroxide plus carbon dioxide will give you sodium carbonate plus water. Even the metal or in the non-metal oxides, that is acidic and basic oxides, combine with each other, but in that case only salt is produced, no water is produced. Like this, CaO plus CO2 gives us CaCO3, a salt. Na2O plus SO2 will give you Na2SO3, a salt. So up till now we have understood that how acids react with metals, with bases and their oxides. And that's not all, acids also react with carbonates. So next property is action with carbonates. In a conical flask, you can take marble chips. With the help of a thistle funnel, you can pour hydrochloric acid over it. From the second hole of the cork, you can collect the gas that is being produced. So when we add lime water in this gas, it turns white. Now why this happens? You see, marble chips are calcium carbonate. Calcium carbonate can be found in many ways. Limestone is also calcium carbonate. Marble chips are also calcium carbonate. Eggshell is also calcium carbonate. So in all these cases, when acid is poured over it, we got a colorless gas which on passing through lime water turned lime water milky. This is a very, very popular and common test for testing carbon dioxide. Now why calcium hydroxide or the lime water as commonly called turns white? CaOH twice, a base, combines with carbon dioxide and what we get is calcium carbonate plus water. You know, the calcium carbonate is only slightly soluble in water. So the particles get suspended in water and it starts looking milky. But if you heat this, the milkiness goes away. Why? Because on combining with carbon dioxide and water, calcium carbonate changes into calcium bicarbonate. So if there is excess of carbon dioxide passed through calcium carbonate, it will become again a clear solution because calcium bicarbonate will be formed. And on heating calcium bicarbonate, again the solution will become milky. Why? Carbon dioxide will be released and calcium carbonate will be again there. So we find whenever acids are poured over carbonates, carbon dioxide is released and salt is formed. So the general equation can be something like this. So acids plus carbonate give us salt plus carbon dioxide plus water. Now because of this property, we use carbonates in fire extinguishers, because in the fire extinguishers, when acid combines with the carbonates, it can be sodium carbonate or sodium bicarbonate, then carbon dioxide is released, which is a non-sporter of combustion. So this reaction is used for extinguishing fire.